In this lesson, we're going to look at arc lengths in space. Beginning with the curve R of t, which we have here with its I, j, and k components, we're going to find the curve's tangent vector. Then we're going to find the length of the indicated portion of the curve. The tangent vector, we call t, is equal to the velocity divided by the magnitude of the velocity. So let's take this up here and let's start by finding the velocity. The velocity is the derivative of our curve. So the derivative of 5 cosine t is a negative 5 sine t, and that is in the I direction, plus the derivative of 5 sine t, which is 5 cosine t in the j direction, plus the derivative of the square root of 2t, which is the square root of 2 in the k direction. So let's take this and we'll move this up here. Take these pieces here. And that is the numerator. And in the denominator, we want to find the magnitude of the velocity. So what we do is we take the square root of our negative 5 sine t squared. So that's going to be 25 sine squared t plus a 5 cosine t all squared, and that's a 25 cosine squared t plus the square root of 2 all squared, so that would be plus 2. So that gives us a tangent vector that's equal to a negative 5 sine of t in the I direction plus a 5 cosine t in the j direction plus the square root of 2k, and all of this is going to be divided by this denominator. Let's take a look. The denominator is the square root of, and we're going to factor out the 25 times the sine squared t plus cosine squared t, and we know that that's 1, plus 2. So this becomes the tangent vector is equal to, and what we're going to do is we're going to take the one term at a time, right? So this negative 5 sine ti. So a negative 5 sine of t, and that's in the I direction, and that's going to be divided by the denominator, and we can see that the denominator is actually going to be 25 plus 2, which is 27, the square root of 27, and the square root of 27 is 3 radical 3, so we're going to have 3 radical 3. That's our first term. Our second term is going to be 5 cosine t in the j direction over 3 radical 3 plus radical 2 over 3 radical 3 in the k direction. And this vector is our unit tangent vector. So let's put a little arrow to t. That is the unit tangent vector. So what we've done here is that we've found the curve's tangent vector. In our next slide, we're going to find the length of the curve between 0 and pi over 8. Here we're going to find the curve length of r, our vector r, this is our curve, between 0 and pi over 8. And in the previous slide, we found the velocity vector and its magnitude. And we found that the magnitude of the velocity vector was 3 radical 3. Let's move that up. So in order to find the arc length L, we want to integrate from time 1 to time 2 the magnitude of our velocity vector with respect to time. I'll take that up there. And that is going to be the integral from 0 to pi over 8. And the magnitude of our velocity vector is 3 radical 3 dt. And we pull out the constant 3 radical 3, and the antiderivative of dt is t, and we evaluate that from 0 to pi over 8. And that gives us, using the fundamental theorem of calculus part 2, 3 radical 3 times pi over 8 minus 0, which becomes 3 radical 3 pi over 8. So this 3 radical 3 pi over 8 is the curve length of the curve r of t from 0 to pi over 8. Here we're going to find the point on the curve r of t, a distance q units along the curve from the origin in the direction of increasing arc. Here's our curve r of t, and here is the distance, 78 pi. So we want to start by saying let's let P of t be the point that we're looking for. Now the length of the curve is going to be the integral from time 0 to some time t, and our integrand is the magnitude of the velocity with respect to time, and I'm going to use a variable of integration, we'll use tau, with respect to our variable of integration tau, which represents time. And what we need to do here is we need to find our velocity vector and the velocity vector and then its magnitude. So let's do that down here. Our velocity vector, v, is the derivative of 5 sine t, which is 5 cosine t, and that's in the I direction, plus the derivative of 5 cosine t, which is a negative 5 sine t, in the j direction, plus the derivative of 12t, which is 12 in the k direction. So the magnitude of the velocity is going to be the square root of our first term, which is, it's going to be 25, or 5 cosine t squared, which is 25 cosine of t squared. Let's put this over. Plus the square of negative 5 is 25 times sine of t squared, plus 12 squared, which is 144. So here, if we factor out the 25, we have 25 times 1, because the cosine squared t plus the sine squared t is 1. So we end up with 25 plus 144. And that gives us the square root of 5 and 4 is 9, 4, 5, 6, 169, which is 13. See if I can squeeze a 13 in there. So what we have here then is we're going to integrate from 0 to t 13 d tau. And that is going to give us 13 tau from 0 to t, which is 13t. So we want to take this value, 13t, which represents our arc length parameter, and I'm going to see if I can squeeze that in here. It's our arc length parameter. And we want to use this equation that the arc length is equal to the arc length parameter. L is equal to 13t. And solve for t. And if we solve for t, we find that t is equal to L over 13. Well, our arc length is 78 pi. So let's put 78 pi in for L, and we end up with t is equal to 78 pi over 13, which is equal to 6 pi. And we want to substitute the 6 pi into t for our curve, r of t, and we get r of t is equal to 5 times the sine of 6 pi in the I direction, plus 5 times the cosine of 6 pi in the j direction, plus 12 times 6 pi, and that's 72 pi in the k direction. And we lose our first term because the sine of 6 pi is 0, and we end up with 5 in the j direction plus 72 pi in the k direction, which means that our point P of t is equal to 0 in the I direction, 5 in the j direction, and 72 pi in the k direction.